let's take a look at the hypothesis test for two proportions. So we've done the independent groups, we did the matched pairs. What's going to happen when we go to proportion-based hypothesis test? Okay, so it says the two proportion samples are always from independent groups. All right, when we do a proportion-based hypothesis test with two samples, it's always going to be independent groups. It's just the nature of the way it would have to work. And so we have the test statistic right there. Remember, the test statistic for proportion-based is a z-score. And you notice a similarity between how we did the independent groups earlier. This time it's p hat 1 minus p hat 2 minus p1 minus p2 over the square root of pq over n1 plus pq over n2, instead of, the original proportion-based hypothesis test, right, was p hat minus p in the numerator. So now we have the difference of two sample proportions of success minus the difference of two population proportions of success. And then the denominator kind of fits the same theme as what we saw with the previous z-score formula. Okay. One thing we need to make really clear, and it's just below. Here, the p is, when we say p, we mean the total pooled proportion. So p appears in the denominator twice, right? P and q. So there's really like three types of p's going on in this formula, right? There's p hat 1, right? And then there's p1, but then a different number completely is just the p. The p is the total pooled proportion. It is found by the total number of successes from both samples divided by the total number of trials. Okay. Also, P1 hat and P2 hat are the proportions of success of the two samples. All right, let's see how this works in an example. It says, in a study on nursing home care, a researcher found that 12 out of 34 small nursing homes had an activities director employed at the home, while 17 out of 24 large nursing homes had an activities director. Makes sense. A larger nursing home probably has a bigger budget, and they can probably hire more. They're more likely to hire someone who's just in charge of activities, an activities director. Where a smaller nursing home, the likelihood that they would have that in their budget, right, is not so good. So what we're going to look at here, at alpha equals 0.05, test the claim that there is a difference in the proportions of the small and large nursing homes with an activities director. Can we show that there is a difference whether you are looking at a small nursing home versus a large nursing home for the proportion, the probability that they would have an activities director? Okay. First thing we need to do, since this is two independent groups, right? The numbers from the small nursing homes are independent of the numbers that you might see in the large nursing homes. One does not influence the other. Since we're dealing with two independent groups, we need to identify those groups. And I think it's natural, you see it there on the screen, it's natural just to say that group number 1, it represents the small nursing homes, and group number 2 represents the large nursing homes, and we picked that simply because that's the order that they gave it to us in the problem. So that will just keep it simpler for us. Okay, so then let's begin by finding, you know what? We're not to the test statistic yet, right? We need to state our null and alternative hypotheses. Step number 1 of the test before I go too far. State our null hypothesis and our alternative hypothesis. Okay, so you're going to find that the null hypothesis looks identical to the way it was done back with the other independent groups, right? Before we had mu1 minus mu2 equals 0, but now it's p1 minus p2 equals 0. We assume that those proportions are the same. For the alternative hypothesis, well, we're going to change that symbol. What would it be here? And notice in the problem it said test the claim that there's a difference. Well, if it's a difference we're looking for, then it's simply a not equals. Okay. At this point, if I ever have a not equals, I like to make a quick drawing for myself. You don't have to do this. Maybe you're accustomed to it by now. But we recognize this is a two-tailed test, so I got my bell curve. Right? We put 0 at the middle for a 2 sample. And then we split the alpha into the upper tail and the lower tail. So in this case, if alpha is 0.05, then alpha over 2 is 0.025, and 0.025, some at the bottom, some at the top. Okay. Now, the exciting part. Let's go about computing all of the different pieces that we need to compute the test statistic here, our z-score. So we'll need P1 hat and P2 hat. Well, reading the problem, if group 1 is the small nursing homes, then P1 hat is going to be found by 12 out of 34, right? Had an activities director, 12 out of 34. And if you round, you will get 0.353. P2 hat, the sample proportion of success for the large nursing homes, 17 out of 24. Turns out to be 0.708. And looking at this, it wasn't like obvious at first, but that's double. That's almost exactly double the probability. Wow. I think we know where this test is going. Maybe. We don't want to speak too quickly, right? But I think we have a hint. Okay, now that we have P1, P2, we need to find P. Remember, P is the total pooled proportion of success. Okay, so what we're going to do is take all of it together. So we take both 12 and 17, add them up. Both 34 and 24, add them up. So we're thinking how many total successes divided by how many total trials. So how many homes had an activities director divided by the total number of homes. So all of it together, not considering one group or another, just putting it all as one, we got 29 over 58, which just so happens to work out to be exactly 0.5, which is kind of surprising, but that's the way it worked here. Okay. Total successes over total trials. Okay, we said that. And we should probably note Q. Well, if P is 0.5, then Q is also 0.5, right? They're complements. And let's note N1 and N2 to be plugged in a moment. N1 is the number of small nursing homes, 34. N2, the number of large nursing homes, 24. And with this, we've got all the information we need to find that test statistic. Okay, I'm going to slide this on up. Here it is. There's a lot happening there, but right, we got P1 hat minus P2 hat minus, again, just like we do with all of these with the two samples, we'll just make a statement about them all. That second portion of the numerator is always 0. You always assume that difference is 0. So minus 0, this goes for every two proportion test. That's going to be 0 because that's our null hypothesis, right? That the difference between those is 0. Then divided by, and okay, big square root, P, the total pooled PQ over 34 plus PQ over 24. Be very careful when calculating that. You should get negative 2.66 when you have it. So make sure you can create that same number. You don't necessarily have to do it in one. I would recommend in one step as far as writing, but you might do several steps in your calculator to get there. Make sure you can get that same value, negative 2.66. Okay. Now that we have our test statistic, we're going to wrap this up pretty fast. The p-value Well, we're going to use our Z calculator in StatCrunch. We got a negative value there, so we're going to use a less than. Right? This number was smaller than that number. Our group 1 was smaller than group 2. So we use a less than. We're on the left side of the bell curve. That p-value is going to work out to be 0.0039. When you round it to 4 decimal places. And okay, comparing that. Remember, we're comparing with alpha over 2. But that p-value is smaller. 0.0039, quite a bit smaller than 0.025. So we will, since our p-value is smaller, alpha is bigger, we do reject the null hypothesis. And if you want a statement, it's kind of small there. Let me maybe zoom in a bit. We say there is enough evidence that there is a difference in the proportion of small and large nursing homes with an activities director. You don't have to phrase it exactly the same way that I did, but you do want to be careful to not say too much or too little. We say there is enough evidence. We're not saying it's proven. We're not saying we know for absolutely sure. We're just saying there is enough evidence that there's a difference in the proportion of small and large nursing homes with an activities director. And I'll tell you what, I know where I'm going. Okay. To conclude this chapter, you notice that just below that practice problem number 6, it says describes the confidence interval for two proportions. We're not going to do an example of that. But you can see the details there. The point estimate is P1 hat minus P2 hat. And the margin of error formula right there. Notice in the margin of error formula, what's under the square root, it's not PQ over N1, PQ over N2, like what we just had in our test statistic. Instead, it's P1 hat, Q1 hat over N1 plus P2 hat, Q2 hat over N2. I won't discuss why that is. It doesn't take a lot of explanation, but I'll spare you that in this video. If you'd like to know why, you can certainly ask me. To find the z-score in the margin of error, of course, that would depend on the confidence level. So if it's a 95%, you find the z-score that goes with it, or 99%, right? Same way we did in Chapter 8. And then you see how to find the confidence interval itself beneath the point estimate minus or plus the margin of error as there. So you will see those in homework, so you'll get practice with that as well. And you may need it for your final project as well. Okay, that's the end of our chapter. Go check out the homework. Good luck.